So next we have solving a system with substitution. So what we're going to do is if it's needed, we'll manipulate the equation so that one variable is on its own side of the equal sign, and it should have a coefficient that is 1, phantom 1. Then we'll determine what one of the variables equals that expression, and then we'll replace the variable in the other expression with the one that is given, or the one that we've made. So at this point now, once you've done that, you will only have one variable in the equation. You just solve for that one variable. Once you get it, you replace that value into the other one of the two equations and then solve for the final unknown. Finally, you're going to want to check your answers on these. So for one like this, here's what I'm going to do. I'm going to take this equation, which represents y, or that expression, and I'm going to take this y here, and I'm going to replace it with this expression. So that y now equals, just as it shows above, negative 2x plus 93. Now you'll notice that I just did that because it was already showing y equals something. I didn't have to manipulate it, so it's just y equals something. It was already there for me. But then we still have the rest of it, right? So this is going to equal 10/3 x minus 147. And so from here, I'm just going to solve this like I would a regular equation, right? Principles of equality. I'm going to do two principles of equality in one. I want all the variables on the left, so I'm going to subtract 93 from both sides to start. Okay, I can drop my equal sign, but 147, negative 147 minus 93. Let's see, that'd be a 0, carry the 1, 5, and 4, 240. A negative 240, thank you. And then the negative 10/3 x, we're going to zero that out as well, or the 10/3 x, by subtracting 10/3 x, that's better. So negative 2 minus 10/3 x, and that's going to be, looks like negative 16/3. So from here, what we're going to do is take the coefficient, negative 16/3, and simply divide it by itself. What this is going to do is it's going to make a phantom 1x equaling, but we got to do the negative 240 divided by the negative 16/3 as well. And this should complete the process for us in solving, at least just for the x. Remember, we still need to solve for the y. Please never forget to solve for the y's. So in my calculator, I'm even using the fraction button there. Looks like it gives me 45. So that's kind of a big number. It doesn't matter how big it is. Okay, so expect some of these numbers to be big, but I can see my x value is 45. Now I go to either one of the equations. I'm going to choose the top one just because it doesn't have any fractions in it. So y equals negative 2x plus 93. And I'm going to replace the x with 45. The 45 that we found, right? So when I solve this, it's going to give me a y value. And I can just put this into the calculator. So negative 2 times 45 is 90 plus 93. Sorry, negative 90 plus 93, which is just a positive 3. So 45/3, right? This should work. We pretty much already checked the top one. Negative 2 times 45 plus 93 is positive 3. But how about the other one? Well, that would have been y equals 10/3 x minus 147. Now, if we've done this correct, we should get a true statement if we replace the x with 45 first, and then also the y value with the y value that we've already found, which was a y value that's 3. So I'm just going to put this in the calculator. 10/3 times 45 minus 147 equals 3, and we get a true statement. So both equations are true when we replace the x with 45 and when we replace the y value with 3. Therefore, we know that that is actually our solution.